Each question has 2 points for the hypothesis. Write it in words and symbols. 2 points for the P and P value, or Z and P value. And 3 points for the conclusion. The conclusion includes your rejection decision. Why did you reject? And then you answer the question. Okay, almost identical to quiz number 8. It's quiz number 9 today. And what is it on? Okay, there's no surprises in this class. 8.2, 8.3, 8.4 is 3 questions, all open-ended. You can do the same thing that you did for quiz number 8. You can do it all on one sheet of paper and just insert it one time, so you don't have to take a bunch of pictures unless it carries over into other pages. Some people were able to just type into the inbox. It works just like Microsoft Word. Okay, if you figure out there's characters you can use symbols. So you just have to click the button that says, when you're in the inbox, it says that's your math symbol. Okay, if you're looking for other symbols, that's anything mathematics. That's anything function symbol. So when you go in inbox, you can just type out like H and then just put a 0, H0 colon. And then mu. Oh, I can't find the mu symbol. It's in there. It's in Canvas. You just type in MU though, if you want to. Okay. So you could write mu representing the population mean. Okay, so that works as well. So sometimes it's easier just to type in your work, because I know some people spend 10 or 20 minutes trying to take a picture and then upload it and then attach as an image. Takes a lot of work, and I get emails all the time. My work didn't upload. Here's an email. Okay, those things happen all the time. So sometimes it's Wi-Fi issues, sometimes it's computer issues. But it makes things easier if you just type in. That could be useful as well, especially when you get to the exam. The chapter 7 and 8 test is 5 questions, and I wrote them as 5 separate questions instead of 1 question 5 times, just so there could be separation between each part. Okay, so if you're gonna do it on paper, then 5 pictures, and you got to upload 5 times. Okay, or you could just take 1 picture and upload it into question 1. It's more difficult for me to grade. Easiest for grading would be if you just typed in your work in there, write out, step 1, hypothesis. You're going to type in words anyways. And then as far as calculations, now we're in chapter 8, and the calculations, we get into some big formulas, and you'll see a bigger formula today. Again, we can go on the calculator. All I'm looking for is a z-score and a p-value. Okay, that tells me you know what you're doing. Statistically, I'm testing you on statistics. I'm not testing you on, can you punch numbers into a formula on your calculator. Okay, most of the time that's where the errors occur. I was taking a physics course one time, and I did a subtraction wrong early on in the question. I got the whole problem wrong, and I was lying through it. Everything was wrong. I was like, well, this is a physics class. I should be graded on my physics understanding, not, hey, I subtracted incorrectly. I had the decimal point in the wrong way. I got the whole problem wrong. That's ridiculous. I don't think people should grade like that. It's all free response. There's no multiple choice on these. The later we get, the more knowledge you need to show. So that's important, that you show all of your work. And then homework. So that's Friday, due by Friday. Again, tomorrow there won't be class, but I made no class. That way you can hopefully work on, catch up whatever you need to. I hope, you're not going to go skip class and be like, oh, I got a day off, party time, right? So I'm hoping that tomorrow, no class, you can find a quiet place. The library is always open here, or even the math center, and you can work on your own quietly somewhere for that. So homework I made due by Saturday. And the problem sets are really small. Yesterday, 6 questions. Most of you stuck around, and I'm sure you got through at least half the homework. So hopefully everyone's on track. Some people finished the homework yesterday before they walked out the door. Today, 8.4, 7 through 15 odd. Okay, a few more problems. So I hope that it's not too much to be able to turn your homework by Saturday. Again, as usual, I give extra bonus points. Turn your work in early, I give bonus points. if you do it in as a Word document. So those things are really helpful when you are trying to score those bonus points. There was a question. I did publish another assignment, an extra credit assignment that's in Canvas. It's called movie reviews. Okay, so you watch a movie. I think there's 15 or 16 movies that you can earn some points watching a movie and then writing something about the movie. Okay, they're all documentaries, mostly involving statistics or collecting data. Data, remember, can be quantitative or qualitative. It could be numbers. It could be information. That's data, right? So collect data, and then what are the results of that data? Like the findings of the data. And several of the documentaries are kind of open-ended. A lot of them are about diet because that's really important nowadays. It has been important since probably, I don't know, the 1990s is when diet became really important, when statistics were showing a lot of people had heart disease. The number one killer in the United States is not COVID, it's still heart disease, heart attacks, stuff like that. Okay, so a lot of people are still dying from that, being having bad health habits. So there's a movie called The Game Changers. Some of the movies you might not be able to find. I wrote where you could possibly find it. You could always Google the movie name, and some of them are on Amazon Prime or Google Play. There's other places where you can find these movies. If there's one that you liked, that you watched maybe, and you're like, oh, this was really interesting to me, I think this would be useful for statistics, and just send me an email and say, is it okay if I watch this movie, and share my information with you. Okay, so the most important thing, I know you can Google the movie, and in Google, it'll tell you about the movie, and then you can copy and paste that and turn it in. Okay, that's what a lot of people try to do. Okay, I'm not concerned about your knowledge of what you saw in the movie. Okay, I want you to include some statistics from the movie. I want you to, most importantly, write a reaction piece to it. Okay, so how did this movie affect you? Did it move you? Okay, or I already saw this before and I think it's dumb, right? There's a movie on there that's called Cowspiracy, and I got that right up before. This was the dumbest movie ever. Cows are causing methane gas, and it's causing global warming, and we need to get rid of all the cows because Americans eat 2 billion hamburgers a year or something like that. So that's your opinion. That's great. I'm fine with that. So all of those are listed, and there's a place where you turn those assignments in. Just turn them all in when you're all done. Again, as usual, just start a Word document, okay, or a Google Doc, and start writing those things up in there. But obviously, first you got to watch something before you can do a write-up on it. And just, again, reaction. So like a paragraph about some of the statistics you saw in there. Like the most recent one I saw, I mentioned, was called The Game Changers. It was about professional athletes and how their diet changed the way they play. Okay, so they were just famous UFC fighter Conor McGregor was like, you gotta eat meat, you gotta eat meat, you gotta eat meat, and meat is like, you're a man if you eat meat, and they're like, no, that's getting all that fat and that cholesterol in your system, you don't perform at a high level like you would if you don't have a bunch of cholesterol or fat in your blood, especially at high pressure situations. One of the oldest movies that's on there is called The Vaccine War. It's all about vaccines, and that's been in the news for the last 3 years. That one's it was published in, I want to say, the late 1990s. It's been around for a long time. It was on PBS, and it just goes in depth about how a lot of parents with autistic children, they felt it happened in the 80s. There was a doctor that said, I think vaccines cause autism. So it's really, it leaves you, it's open-ended, but it makes you think, like, where are all the doctors in the world saying, what are the parents saying, and who's right? So it was interesting because, like I said, the last 3 years, highly charged debate, should you get a vaccine or shouldn't you? Well, they talk about how vaccines are created. I saw a documentary on, vaccines are created. A lot of people a lot of people say, like friends and family, most of our information now comes from, Facebook and places like that. And everyone's like, oh, fact check, stuff like that. Anyways, a lot of friends and family would say that what they saw was, that vaccines were created too quickly, right? In order for it to be healthy, that's going to kill you and all that other stuff, right? So the technology has changed, over the last 30 years. So that might be the case 30 years ago, but the doctors and all the, pharmaceuticals, oh, they were in it for the money and they got, $1 billion from the government, to do this. And the CEO just retired and got $900 million for retiring. Or whatever money, everyone thinks it's money driven and conspiracy theories and all that stuff. But I did see a documentary. I can't remember what it was, but it was the person that created the vaccine, and came up with all these ideas. So I think it's just interesting. I'm not for or against it. I don't have an opinion really about vaccines. But the vaccine war documentary really gives you some data and makes you think, right? And just apply it to today, because this is not, everyone thinks it's brand new because of social media, but this debate has been going on for a lot of years, for a long time, right? And especially females, if you're pregnant, right, you're gonna be like, should I vaccinate my kid? And I've had people ask me that, what do you think? I'm like, well, watch this movie, see what you think, because vaccines cause autism. That's what the parents say, and a doctor in the 80s. So who knows?
I did a while back, I actually researched that specific study, the vaccines causing autism.
Yeah.
Not only was it a pretty biased study, but the doctor who was like the main conductor of it got his medical license revoked.
Yeah, that's
so
they go into that in the movie,
Yeah.
that he lost his license and things like that. And he's like, oh yeah, you're right, and just listen to the parents. And the thing is, a lot of people are more vocal about things nowadays than they were a long time ago, So like when they had the Spanish flu, people didn't like go protest, So the things have changed and people are just more vocal, and that the people that are vocal are famous people, and one of the famous people, I think she's a judge on the Masked Singer. She was like one of the most vocal people, and so we're like, oh, famous people speak, then all of us lay Americans listen, right? Like, oh, they know what they're talking about. Anyways, yeah, I try to stay away from politics and stuff. I'm neutral in that situation, but I think that's really interesting. Use the data, and see where it takes you. A lot of people are against, Dr. Fauci, but he's actually, if you look back, he helped with the AIDS pandemic in the 80s, and that's what he was known for. And he just grew into this position, but he helped, he didn't cure HIV or AIDS or anything like that, but he helped prevent the spread of it and did a lot of research in that field. So yeah, do your research, look at data, collect information. Don't go on Facebook and get your information, or whatever social media, TikTok, whatever they say, or friends or family, what my grandma says, that goes, that's usually what happens. Anyhow, we're talking about collecting data and comparing two sets of data. And I used the analogy the other day of taking an experiment group and a control group, collecting the data, and then comparing the results. Okay, so we have two sets of data. Comparative studies are more important, not more important, but they carry more weight than looking at a sample and comparing it to a population value. Okay, so if I know that texting while driving is not good, right? If you're texting while driving, it could be a dangerous situation. So how do we know? Well, data has been collected for a long period of time. Studies have been done for a long period of time. I saw a map of the United States in 1960. The number of deaths by texting and driving in 1960, there weren't any in the United States. People didn't die from texting and driving in 1960. There weren't cell phones, but I thought it was funny. There have been a lot of studies done, and we need two groups. right? We need a control and a treatment group. We need a group to be driving without texting, and we need a group to drive and text. It could be dangerous to have people go do it. Okay, I'm gonna have you all, this group, you guys are gonna get in your car and go text your friends and family and go drive around the town, see if you get in a car accident. That could be dangerous, right? So it's probably not gonna happen. Usually we use driving simulators, so there's another, when we were talking about observational studies, surveys and experiments, we talked about simulations. So a simulation of driving while texting might be better to collect data. But this, what we're doing now is really useful, taking two sets of data and comparing them. Okay, 30% of people texting and driving ran a stop sign. Okay, 20% of those that were not texting and driving ran a stop sign. Okay, let's compare those proportions. And that's what we're doing today in 8.4. We're gonna see if there's a difference between the two proportions, or if there's no difference. Okay, so that's the ultimate goal with statistics, is to make a conclusion, and it's called inferential statistics. We're gonna make a conclusion about a population. Okay, so what's really important when we write our hypothesis, if we're doing a 2-sample study comparing means, notice that these are population mean. So if I take a sample and compare it to another sample, and there's a difference, one sample was bigger than the other sample, then we conclude that that would be true for the population of that sample. So again, with the texting, if it happened for 50 people, it would probably happen to everybody. Okay, it's kind of a slippery slope idea in statistics. If it happens for this sample, this group, then it's probably going to happen for everybody. All right, so that's the idea of statistics. And a lot of times you see like statistics and studies, and you got to know where your data is coming from. Okay, so you don't want to take data from the deadliest animal in the world, not a shark. I think 900 great white shark attacks since 1960. The deadliest animal in the world is a mosquito. Kills more people than any other animal in the world, the insect, right? People get the virus from the mosquito. But are we worried about getting a mosquito bite here in Santa Maria, California? Probably not, right? I haven't gotten bitten by a mosquito in quite a very long time, I must say. My wife thinks I'm immune somehow. I'm like, I don't wear fragrances. I don't know, maybe they're attracted to that. But if you're in Africa, you live in Africa, that statistic might be really important to you. Okay, you might be, oh, okay. Another thing that causes a lot of illnesses and deaths that we don't even think about living in the United States is water, right? In India, more people die from waterborne viruses than any other illness. But we don't really have to worry about that living here. We got nice clean water. We're pretty lucky. So where is your data coming from? And your data is coming from a sample. We take that sample, it's at X bar, and we apply it to a population mean. It could be true for the sample. If it's not true for the population, then that's where the type 1 and type 2 error come into play. We could have made a mistake. It's just because this sample was different than the population value. Type 1 error means we reject when we shouldn't have. Type 2 error is when we fail to reject, when we should have rejected. All right. So I was just trying to give you a breakdown of everything we've done. If you've been confused or anything like that, just on the quiz, I did see that 3 people went back and went through the quiz again. So that was pretty cool. Just to shore up some things. I can try to give you feedback so that way you actually know what you're doing. But like I said, remember day 1, I was like, if you're here every day and you're in class and you're doing your work, you're gonna pass. It's gonna be fine. A lot of people are freaked out. They're like, this is my second time taking. You're gonna be fine, right? So some people are struggling a little bit, but I'm just trying to make sure that you're getting the feel of it. Any questions on chapter 8.1 or chapter 8.2 or chapter 8.3? I know 8.3 is a little out there comparing dependent samples. You might be stuck on a couple of things there, but
Number 10 for
okay. The first one was number 10. SAT scores. You know, I'm gonna write down the data so that way we can see it. I'm gonna do it vertically. So that way I don't, well, maybe I'll write it up high. I can't reach that high, I'm short. 300, 400. 450, 520. 350, 400. 430. 300, 340. 475. Okay, the first thing that I see when I look at the data, the top row is the first time they took the test and the second time. So I'm going to use different language a little bit before they took an SAT preparation course and then after taking an SAT prep course. Okay, there's a confounding variable here. If I take the SAT and I wait 2 weeks or 3 weeks or whatever it is and go back and take the test again, I'm probably going to do better. The first time through, not going to be very well. I'm not going to do very well. Same thing in any kind of test that you take or anything that you do, right? If you want to be a nurse and you go into an interview to become a nurse, you don't know what to expect. But the second time you go to your interview, you're going to know what to expect. You're probably going to do a lot better. Same thing with SAT. So a confounding variable is the fact that you've taken it already. And the second time, your scores are probably going to be higher. So did taking a course help improve your score? Right now, before I even do any statistics, a lot of times we get tunnel vision and we just focus on, is this a C test or a D test and what do I got to do? Just think about logically, use reasoning and decide, will an SAT course improve my score? Okay. And I'm thinking yes. It's a yes, no question. I'm going to write it as a yes, no question. Does the SAT course help improve scores? So that's the importance of writing it in words. This is why I'm really a stickler on that. The book is not really a stickler on writing it in words and symbols. They just want the hypothesis pretty much. But I like the words because I'm going to ask a question and then when I answer that question, does the SAT course increase scores? That's a yes or no. The answer is either yes or no. I need evidence. I need data to tell me. There's the data. Are these numbers bigger than those numbers? Yeah. Okay. We should be done by now. And I actually had students in the past, they didn't know much statistics. They just came and showed up whenever. And then like, I'm going to try the test and they would just write the question and write the answer. Yes. Okay. I'll give you a point for that. You know, I mean, hey, you answered the question. You wrote a question, but I obviously follow a rubric. So I'm going to write the hypothesis. These are dependent samples because the same person took the test twice. This person number one took the test twice. When we have dependent samples, sample sizes are the same. I'm going to do what's called a paired t-test. So I'm going to compare the mean difference. It says increase, so I'm thinking greater than 0. And I know you have access to answers. And if you look at the answers, they don't do it this way. I'll show you the other method of doing this after I'm done with this. I think the word increase or higher than or above or greater, all those things mean greater than. So that's how I'm going to write the question. I'm going to write the question and my hypothesis is gonna match that question. Again, the book kind of sways away from that because the author of this textbook, Mr. Larson, this guy, Ron Larson, he's authored hundreds of textbooks. So he's not an expert in statistics. He's just a big name in the math world, and he authors all kinds of books. Sorry, Mr. Larson. I didn't mean to clown you like that. If you're watching. All right. I need statistics now. I need a T and a P value. Well, I'm gonna get some information. I'm comparing the differences. I could do a 2-sample P-test and compare those like I showed previously. Is the first sample or is the second sample, are all these numbers bigger than all those numbers? I could do a 2-sample, list 1, list 2. So this begs the question, am I gonna, in list 3, do L2 minus L1 or L1 minus L2? Well, I have to think what will give me positive numbers. Any number above 0 is positive. If it said less than, I want negative numbers, okay? So right now I'm doing a greater than test. So in list 3, I'm gonna do a bigger number minus the smaller number. The bigger number is in list 2 minus list 1. If you enter the data that way, if you enter these numbers in list 1 and those numbers in list 2, you're gonna do L1, or I'm sorry, L2 minus L1. Okay, that's what most people do. Most people will see the first set of data. That's gonna be my list 1. If you enter these numbers first and put those numbers in list 1 and these numbers in list 2, I'm going to do an L1 minus an L2. Okay, so that depends where you put your data. So I'm going to find the differences. I can do that on my calculator, or I'm actually going to do this in my head. I'm going to subtract the bottom numbers from the top numbers. And these are the numbers we're going to test. Looks like they're all positive, and they're all far above 0. Are all those numbers combined greater than 0? Well, now I'm going to look at the mean of all those numbers. That's called, in the book, they call it B bar. And again, why are we creating new language? We don't need new language. We already have the sample mean. It's called X bar. I just put a subscript there to represent the mean of all those numbers. Let's add them all up. 100, 220, 280, 320, 430, 460, 490. I can't do my math now. 560, 590. 590 divided by 10. 59. Standard deviation, a little bit more difficult to calculate. Standard deviation was from 2.4. Standard deviation for the difference. Did anybody read example 1, example 2, and 8.3? They calculate standard deviation using this big crazy formula. Well, what's the shortcut? I can put all these numbers into a list, into list 3, and I'm going to do a 1 variable stats for list 3. 1 variable stats. And notice that I'm doing all this in step 2. That'll give me the X bar, and that'll give me the standard deviation for the difference. Did anybody get that standard deviation? On problem number 10, I don't have my calculator in front of me. Standard deviation 60. On the mean 60. And what's standard deviation? Amen. 8. 0.8. Oh, 28. Okay. Sorry. I have terrible hearing. But I have 20% hearing loss. I went and got a hearing test, and I have 20% hearing loss in my left ear. That was like 5 years ago, though, so it's probably worse now. I tell my wife that, and she doesn't believe me. She always says, "You're just making excuses. You didn't listen to me." Well, I'm like, it's the same thing as having bad eyesight. Take your glasses off. She wears glasses. Take your glasses off, and tell me what this says from, across the room. I can't read that. Well, I can't hear you from across the room. So it's the same thing. Yeah, hearing and seeing. It's equivalent. Doesn't come out that way though. All right, we're gonna do the calculation. We're gonna find a T and a P value. Well, I don't need to go into. I'll show this video to my wife. She'll watch it and she'll shut it off after like 2 minutes. I offered her to watch a video. I watched one of the videos because I was uploading them to YouTube. I don't know if you noticed that. Anybody see that? I uploaded the videos to YouTube. I have a YouTube channel called Mr. Silva. And all my videos are on there. So far up through chapter 7, I believe. So I was trying to get her to watch it and she's like, no, thanks. I told her she's gonna have to take this class one day. She never took statistics. One day she's gonna have to take it. Anyways, we're gonna get T and P value from list 3. Make sure you use list 3. Anybody get a T and a P value?
T score is 0.
I'm sorry,
6.8.
for T?
Yeah.
6.8 for this? Okay. Ooh. So here's an important point. If your T is small, you're gonna have a big P value. If your T is really big like this, you're gonna have a really small P value. And it's not gonna be 1.2 or 3.7 or 6.8. It's not gonna be a decimal. It's always got an E negative something. Yeah, I'm pretty sure it's gonna have an E negative something. And what number did you get? 3.9 E negative what?
Oh, negative 0.5.
E negative 5. That just means 4 zeros. Move the decimal to the left 5 times. 4 zeros. 3 9.
This is because on the calculator, we did t-test data, mu 0 equals 0.
Yep. The population mean is, and a good point, in a lot of statistics class, and a few people did this. Either the mean is 0 or the mean is greater than 0. It's unrealistic to say that these numbers are less than 0. Either those numbers are equal to 0, that means there's no difference. Or those numbers are greater than 0, that means there is a difference, okay? But this is, like I teach another statistics class using a different program, different book. And we use this method because this makes more sense. If you really understand that in-depth statistics, that if I put equals 0 there, that means either all these numbers add up to 0 or all those numbers are greater than 0. It's again, unrealistic to think, oh, if I take an SAT class, my score is going to go down. It doesn't make any sense. So it's kind of unrealistic to put a less than equals, but I mean, sometimes that happens. Like when we measured the Snickers candy bar. Remember the Snickers candy bar? We thought they were going to weigh less than what they claim. They actually weighed more than what they claim. So it's possible in some cases you would get the opposite of what you think is going to happen. The opposite happens. That's just statistics. Step 3, we're going to make our rejection decision. We reject HO, Y, P value is low. And I'm just sticking with 0.05. People, you're going to email me quiz number 9. Quiz number 9. What's the alpha significance level? It's not on here. 0.05, right? Now we're going to answer the question. Which one is it? Is there no difference or is there a difference? Are those numbers bigger than 0? Are the numbers bigger than 0? It looks like we rejected. Reject means not that one. It means this one. The mean difference is greater than 0. Does the SAT course increase scores? Yes. There's evidence.
For the calculation, you do want the mean and the standard deviation.
These values right here. There's 1 point for the t-score and 1 point for the p-value. So that could be helpful, okay, if you put it in there. But if you get the wrong t and the wrong p-value, but you have the correct these numbers, then I can give you credit. I give you partial credit if you get those numbers wrong. Like it's worth 2 points if you got both these numbers wrong for some reason, because you entered the numbers incorrectly. I would see that right here.
Okay.
Make sense? So I would include in the calculation portion, I would include everything that you need. I would include degrees of freedom. Okay, N is 10, degrees of freedom is 9. In the book, they're gonna say, what's your critical value? Right, so you can include that as well. You can draw a curve. A lot of times, when it's not summer, if you're gonna take my class again, I ask you to draw a curve. Okay, in fall and spring, I usually teach this class and I draw the curve pretty much every time we do a statistical test. That's something you would put on here. Okay. There's evidence SAT course helped increase scores. And that's what I thought before I even did statistics. Our statistics tell us the scores went up because you took a class. I had a friend in high school. I had better grades and I had a lot more knowledge than him. He took an SAT class for like 16 weeks at UCSB. He went every Saturday for 8 hours for 16 weeks. He scored way higher than me on the SAT. He got into Cal Poly and I didn't. Okay, because he had high SAT score. I was like, I'm way smarter than you. How'd you get into Cal Poly? Oh yeah, he took a class, an SAT class. It increased his SAT. So it's something that you could study for. It's something that you can gain knowledge from before you even take the test. And this might be one of the reasons why they got rid of the SAT test. I could do this question the same. Does SAT course help increase scores? Question mark. This is if you're Googling the answers. And I get a lot of students that do that. Well, this is what the book said, and then you have no idea why they said that. Because this is Mr. Larson's idea. That's the first set of data, and most students are going to enter those numbers first. And then you're going to enter those numbers second. And then I want to know the before and the after. Are your scores lower? Are these scores lower than those scores? Okay, are they lower? So here's the difference. Now I'm going to do a L1 minus an L2. This is not rocket science. All those numbers are going to become negative. Guess what happens to the sample mean? Becomes negative. Guess what happens to the standard deviation? Nothing. Standard deviation is still a positive number. The spread, how spread out are those numbers? They're spread out by 28. Yeah, that measures the spread. My calculations do all the same thing. My t statistic is negative. If I did a left tail test, means I'm doing a left tail test. My t is now going to be negative. My p-value is going to be the same. What's my rejection decision? I do the same thing. Reject because p-value is less than 0.05. So I reject. Okay, what does that mean? The mean difference is less than 0. These differences are all less than 0. That means the before scores are lower than the after scores. That tells us the same thing. The SAT score or course helped improve or increase scores. Okay. The calculation is still the same. We just get a negative because we're doing a left tail test. Okay. All those numbers are negative now. So again, you could do pretty much all these. If it's a less than or greater than, we could use either method. Okay. Both work. Both are correct. Both will get you full credits. So that's number 10, page 442, 8.3, SAT scores. I thought you were going to say 14. 14 is a trick one because they said that vitamin C help increase grip strength, but the opposite happens. People lose grip strength when they take vitamin C for some reason. Maybe it's because they did this muscle endurance before and after placebo. I don't know. This it's a weird problem. Anyways, the question was, how about 18? The scoring averages of 10 basketball players, their rookie and sophomore seasons are shown. Do they score more points their second year playing basketball? It says professional basketball players. I'm assuming the National Basketball Association, which is the NBA. And they even in the All-Star game, NBA All-Star game, they have a before the day before the All-Star game, they have a 3-point contest, and then they have a game. It's called the rookies versus, or the first year, they call them rookies versus the sophomores. The first year versus the second year players. Pretty entertaining game. It's pretty cool idea, pretty fun. So this is where the data comes from. Is there enough evidence to support the claim the scoring averages have changed? This is equals and not equals. I'm not going to do a greater than or less than. So my calculation, it doesn't matter how I subtract. It does not matter. Because when I get my Z or my P statistic, I get a P value and I multiply by 2. That P value is the same if you have negative means or positive means. So my hypothesis is going to be, is there evidence have scores changed? Have point totals changed? So this is equals and not equals because there's no less than or greater than. We're not. Okay, my assumption is that your second year in as an NBA basketball player, you're going to score more points. Does that make sense? I think your second year player is going to be better than a first year player. I know this. I always want to teach a class called Statistics in Sports. There's actually a book out there with that. I like sports, but there's a game. I'm not a gamer. I don't play games. But there's a game called Madden. John Madden was a famous announcer. Madden 2023. And there's a player in the NFL. His name's Jamar Jefferson. He plays for Minnesota, I believe, and he broke the record for rookies for receiving yards. And his Madden score is ranked like the 10th best receiver in the NFL. So he's really upset. And then Tom Brady said, "Hey, I didn't even get a Madden my second year playing." You know, it's pretty funny. I don't know if you know football or even who Tom Brady is, but your second year in the league doesn't reflect your overall career or your rookie year. Are these numbers different? Are these numbers different? So I'm going to find a P statistic and a P value. I want to find the mean difference between all those numbers. The first player scored 18.5 points as a rookie, went down by 1. So that's a negative. The second year player went up by 1, or the second player went up by 1. Third player went up by 0.8 points. Is that a big difference? Not really. You average 16.1 points as a rookie, 16.9. Is there a big difference between those numbers? I'm looking at the numbers without even doing any calculations. Have point totals changed? I'm thinking no. However many points they scored as rookie is about the same they scored as second year sophomore players. Really no difference. What does our calculation say? Calculations, X bar is 1.2 or negative 1.2, depending on how you do the calculation. The standard deviation is 3.05. And you do not have to include this if you don't want to. I'm going to calculate T 1.2 over 3.05 divided by the square root of, I think it's 12. They looked at 12 players. No, 10 players. And it's 10. Square root of 10 is, square root of 9 is 3. So 3 divided by 3, like 1. 1.2 divided by 1 is about 1.2. So my P is going to be pretty close to 1. One-ish. You may get it? 1.3, yeah. Pretty close. P-value, I'm pretty sure the p-value is gonna be large. And remember, if you look up this, or you do a TCDF, or look up this P statistic of 1.3, you'll get a p-value, and then you gotta multiply that p-value times 2, because it's a two-sided test. But my p-value 0.34.
21.7.
Where?
I'm assuming that's times 2, right?
No, if you do a t-test on your calculator, that p-value is already multiplied by 2.
You said it didn't matter if we which way we subtracted this one. or
Right.
this two.
If this is negative 1.2 or if it's positive 1.2,
Okay.
when we do this math, if it's 1.2 divided by this, I would have 1.3. If it's negative 1.2 divided by this, I would get a negative 1.3. Now you still give me a p-value of 0.21. Either way, I still get a positive p-value.
You don't see it. And
So
then-
we don't have to multiply by 2.
Okay.
So now we're gonna make our rejection decision. This is step 3. It's 3 steps, 3 points in our rubric. Fail to reject HO, 0.21 is greater than 0.05, or in this case, 0.1. Alpha is 0.1, still greater. We're going to answer the question, have point totals changed? There is not enough evidence that point totals have changed from rookie year to sophomore year. Now, make a little bit of sense, yeah? Makes some sense, I hope.
I don't know, when we did a particular, is a different answer.
It's a slight, it might be slightly different, yeah. But you're still, are you gonna reject or fail to reject?
Is the rejected plan? Reject.
Are you sure? Let me look. Do they think you're still gonna fail to reject? Because. Yeah, so my answer says fail to reject. There is not enough evidence to support the claim that players' scoring averages have changed. So the answer is fail to reject. So that was the equals and not equals, and to be honest with you, on the quiz today, it's like one of those. I think, I'm pretty sure on today's quiz number 9, it's the equals and not equals. Is there a difference or is there no difference? That's what we're looking for. All right, so we spent a lot of time on that. We spent 50 minutes. Okay, that was really important to spend that time going over some things, 8.3, pretty tough stuff. And it's good news. We have 2 options today. Like before, we can, well, not really 2 options. You have 2 options. I'm gonna go over 8.4 right now, and you can stay and work on homework, or you can go take the quiz somewhere else. Right, that's fine with me. You stay here and work on the quiz if you want to, or you can leave and take the quiz somewhere else. Till you have an 11:59 p.m. Hopefully you don't wait until 11:59 p.m. to start the quiz. But this 8.4 is very short. Mirror 7.4. Test for proportions. That was about 5 pages. This 8.4 is 4 pages. There's 2 examples, and most of the information is doing a test for 2 proportions. The calculations for doing the test for 2 proportions. They get into this P bar and Q bar and combined proportions and checking conditions N1 P1 and 2 P2 and all these other things. So there's a lot of information in there that to me is a waste of time. It's a lot of extra work for something that we already know. We already know how to write a hypothesis.
Sorry, for the number 3, did you say is enough evidence or not enough?
For this one?
Yeah.
Yeah, we felt whenever you fail to reject, there is not enough evidence but there is a difference. There's not enough evidence of HA. So whenever we reject, we say there is evidence of HA. There is evidence, there is a difference. Whenever you fail to reject, we would say there's not enough evidence that there is a difference. Mhm. And I'll leave those, I'll get those notes for you. I'll rehash those notes. And after I go through this. All right. We're gonna compare two proportions. Yes, no question. I go and do a survey. I usually will typically do a survey in my class for my student, for you. I would do males and females, but we only have one male in here and that sample size is a little too small. Well, there's two of us, all right. But small sample size, so I got to get some data from the college population. So a simple question would be like, I want to know, is there a difference in the proportion of males and females that have a tattoo? Is there a difference? Or is there no difference? Or is one group greater? I think more males have tattoos than females. Greater than. One proportion is bigger than another proportion. We have three ways to write the hypothesis. How should we write the hypothesis? Well, again, there's three ways to do this. Just like means, just like P testing and Z testing, we're going to compare two proportions. Is P1 and P2 equal, or are they not equal to each other? P1 bigger than P2? Is P1 less than P2? Okay, again, it's really important what you call your 1 and your 2. Okay, make sure you look at your statistics with proportions. Sometimes we get the date, sometimes we get the data, the numbers. Like P1 is 27 out of 40. P2 is 30 out of 40. Let's compare those two proportions. And other times they'll give us percentages. Well, we got to find the X and the N, because ultimately we're going to do some kind of calculation. So in step 1, we're going to write the question. So what's our question? Are we going to write the hypothesis? One of those three. Step 2, we're going to do our calculation. We're going to Z a p-value. Again, I'm not going to go in depth on how to calculate the Z score. P1, P hat 1 minus P hat 2 over P times Q times 1 over N1 plus 1 over N2, page 448. You want to know how to calculate the Z score? Page 448. Or we're comparing two proportions. So I need to know my calculator input here. In order to get these numbers, I'm going to do a 2 prop Z test. There's extensions in the back of each section, and we got into 2 sample Z tests, 2 sample P tests. There's also intervals. If you read the extension, there are some problems in the book about confidence intervals for 2 means. There's confidence intervals for the mean difference, 8.3. There's confidence intervals for 2 sample or 2 proportions. We do intervals. INT means interval. Okay, but now we're testing, and we're going to compare the difference between those 2 tests. So we're going to bypass a lot of stuff. I'm just going to go into example 1 on page 449. Page 449. Example 1. A 2 sample Z test for the difference between proportions. And we're going to do half the page is the calculation. Doing the Z calculation takes half a page. When we could just punch it in our calculator, we are allowed calculators, let's use them. Okay. Thank you, Texas, for creating this calculator. A study of 150 randomly selected occupants in a passenger car and 200 randomly selected occupants in a pickup truck shows that 86% in passenger cars, 74% in pickup trucks wear seatbelts. Can you reject the claim that the proportion of occupants who wear seatbelts in the same passenger cars and pickup trucks? Okay. We're gonna do that one. How do I know? Because I assume more people, this is just my assumption, because I was a kid once in the 80s and I rode in the back of a pickup truck with no seatbelt or nothing. And I drove to like out 166 to Cuyama, right in the back of a truck before, as a kid. I didn't die. I'm still there. I got lucky, I guess. Oh, the speed limit was 55. Some trucks didn't even have seatbelts. A lot of those trucks had gun racks in the back of the window. That was legal too. Things have changed a little bit, but I assume that less people wear seatbelts in trucks than in cars. I don't know why. But that's not what the question asks. The question asks, is there a difference? Is there a difference? Or is there no difference? One or the other. One or the other. I'm going to calculate a Z. Okay, this is where it gets tricky. P hat 1 is going to be cars. P hat 2 is going to be trucks. Actually, I'm going to define my variable. P1 is the proportion of people wearing seatbelts, proportion of seatbelt wearers in trucks. Or I'm sorry, P1 was car came first. And just to follow P2 is proportion wearing a seatbelt in a truck. And if you saw my answers, sometimes I just write P1 car, P2 truck. But what does it really mean? We're taking a sample. This is sample information, 75% or 74% and 86%. We're going to compare those two proportions. But when we do this on the calculator, we need to know what is P hat 1 and what is P hat 2. So this is like kind of hidden there. We got to do the N times P thing. Okay, they said 74% of occupants in trucks and 86% of passenger cars. There are 150 people surveyed that were in a car. 86% of them had seatbelt. So this is 86%. This is 150. The question is, what is X? I know that I got 150. So 86% of the 150 people in cars wore a seatbelt. 86% of 150. Of means multiply. On your calculator, 0.86 times 150. That'll tell me how many people were wearing seatbelts in the car. So you actually have to do a little bit of math. And remember, we cannot have a decimal. We always round up. So anybody do it? 86%. 129. That sounds right. Thank you. 129 car passengers wore a seatbelt out of 150. You have 2. So this is a little calculation. 200 truck passengers and 74% were wearing a seatbelt. What is 74% of 200? 48. Thank you. I was trying to do it in my head. I was right there. I was so close. I was just trying to multiply 74 times 2. There you go. We're going to compare those two proportions. Let's compare them. Maybe people feel safer riding in trucks because they can run other cars over, you know? No, so I have a theory. You notice when it rains, it doesn't rain here very often, but when it rains, a lot of people drive really fast in the rain. Years ago, people didn't drive very fast in the rain. Cars are just a lot safer now. So people feel safer, and especially, I'm guilty of this. Got new tires on the car, got a new car. I can do 75 in the rain. I'll be able to stop. I got new tires, right? So people just feel safer. I got a BMW X5, safest car on the road, right? I bought one, 2003, had it for 10 years. And I felt safe in the car because car and driver said it was the safest car on the road. So I drove a little faster in the rain until I had kids. Eventually done. Is there a difference? Let's do a 2-prop Z test on our calculator. Let's go for it. Calculator, 2-prop Z test. What's X1? What's N1? We calculated those already. And we could actually do that calculation right here where it says X1. I could do 0.86 times 150 where it says X1, and it'll calculate it right there. I just try to avoid that because sometimes it puts in decimals and you get an error. Anybody ever get an error this semester and be like, what am I doing wrong? Screwed. Okay, well, it's an error. It just means you punched the wrong button. You got a decimal there. Okay. This is X2, that's N2. Not equals, less than, greater than. We're going to choose not equals. Did we answer all the questions? Are we ready to calculate our Z-score? Yeah. I'm looking at the look at the calculation there, it's halfway down. They do check conditions. Okay, I'm not really a stickler on condition checking. I'm a stickler on asking the question and answering it. They said the Z-score is about 2.73. They used a rejection region once again, but we don't need a rejection region. There's a picture of it on page 449. I am curious what the p-value is. It's going to be small p-value, 0.00 something, right? Thank you. I could have just looked up 2.73, or actually negative 2.73, got the p-value multiplied by 2, 0.003 times 2 is 0.006. I'm ready for my conclusion. Let's see here, reject or fail to reject. What do you think? Is that a low p-value? Reject. Why? P-value is low, below 0.05. This p-value is below 0.01, and this p-value is below 0.1. There's evidence of a difference. The proportion of people wearing seatbelts in cars is different than the proportion of people wearing seatbelts in trucks. Now, I can't say greater than. I can't say greater than. I can't say more people wear seatbelts in cars than in trucks. Unless I did this right here. If I did this test, then I would conclude that cars seatbelt wearers is greater than truck seatbelt wearers. Wearing a seatbelt in a car versus a truck. Interesting. Example 2, pretty much they gave us, it is a little different. In example 2, they give us X1 and N1. They give us X2 and N2. All we gotta do is punch the buttons in to the calculator. I get a really small p-value. We reject. Medical research tests the effect of cholesterol medicine. I just want you to read the question and then read the conclusion for this problem. Actually, look at the Z-score. The Z-score is negative 3.4. P-value is going to be really small for a Z-score of negative 3.4. So just read the question on page 450. And you can punch the buttons in and practice doing a 2-prop Z test on your calculator. I'm going to give you about 5 minutes to do that.